Hello and welcome back to our webcast series on plane and descriptive geometry. In this video we're going to look at another one of the key principles of geometry, which is how to locate the point view of a line. So in a similar way to our last video on how to locate the true length of a line, locating the point view is one of those key principles that kind of founds the bedrock or foundation of all the various properties and principles that come after it. So having a good understanding of how to locate the point view of a line is really useful for all the other topics that you're going to learn. So what we're going to start off with here today is just by looking at what is the point view of a line, how do we go about finding it, and then we're going to look at the different scenarios that you're likely to encounter when it comes to your own drawings. So we're going to begin with just a little bit of a background, and that's first of all that every line is made up of 2 points. So the definition of a line is the shortest distance between 2 points. So that's what a line is. It's the shortest distance between 2 points. And if we take the example here of a line as a pencil, so we can see the 2 points that we're dealing with are the front of the pencil and our back of the pencil here. So the front point and the back point. Here we have the side elevation and here we have the front elevation of the one pencil. So viewing a line as a point results in both points appearing as a single point. So if we take the example of our pencil here, what that means is that if we look along the pencil like so, the front of the pencil and the back of the pencil will appear as one single point. And that's what the point view of a line is. It's when the front and the back points both appear as one single entity, one single point. As we said already, to see the point view of the line, you must look along, or in graphical terms, parallel with the line. So we can see here, we're looking in this direction here, we're looking along, parallel with the line itself. So that's how we go about finding the point view of the line. Also, if we're looking along a line, we need to project it onto something. So a point view is projected onto a plane that is perpendicular to the true length of the line. So if this is our true length line here, this is what we see in our side elevation, the plane we're projecting onto is at 90 degrees to it. And here we can see the outline of the plane when seen straight in as we look in at the point view of it. So the position of the plane is always projected perpendicular to the true length, and that's very important. It has to be to the true length of the line. So that's basically the background really when it comes to the point view of the line. What we're going to do then is we're going to look at the various scenarios that you're likely to encounter through your own drawings. So we'll just set it up here where we have a single line. Here we have the front elevation of it, here we have the plan view of it, here we have our 3D view of our line. In order to find the point view of the line, like we were saying there, you must first of all locate the true length of it. So you'll remember from our last video that because this line is horizontal in elevation and plan view, well, when we look in from the front, we're looking perpendicular to the line. So when it's projected into our front elevation, it's going to be a true length. So the front elevation here is already a true length. Same thing applies when it comes from our plan view. Because we're looking straight down on a horizontal line, when it's projected to plan, it's going to be a true length in our plan view. So our plan view and our front elevation are both true length lines. So in that case, we don't really need to worry about which view we're taking to look along. So if we want to look along our line like so, we can take the front elevation or the plan view. Just for handiness sake, I'm going to take the front elevation for this example. So we look along the line. So this is the direction we're looking at. And we're going to place our XY line, known as the YY line, because what we're drawing here is an end view. And that's going to be the plane at 90 degrees to our true length line. So there's the plane in our 3D view, and we're just projecting our line along to give us the point view of the line. So in our front elevation, we're just projecting along our line of sight, and you can see the front point and the back point are both carried along this single construction line. So we do the same with our plan view. We draw a little 45-degree line here to transfer it across. Point A and B goes across and it's transferred up again on one single line and gives us our point view. So A and B are now contained in one single point, which we just call AB. So that's the point view of our first example there. In our next example, we're going to have pretty much the same thing. The only difference here being that the front elevation of the line is horizontal and the plan view of the line is angled towards us. So like that we were saying before, from our last video, we'll know that looking from above, we're looking perpendicular to our line, so that's going to be projected down as a true length in our plan view. So the plan view is going to give us the true length of the line. When we look from the plan view straight in, because the line is angled towards us, it's not going to be a true length in elevation. So that tells me that I'm going to be working from the plan view. You're always working from the view that you have the true length of your line in. So like the last example, we're going to look along our true length line. So we're going to project our plane at 90 degrees to the true length line. There's our x1, y1. There's the plane like so. So the x1, y1 being the edge view of this plane here. We project our line onto it to give us our point view. Same thing applies here. We're continuing our line, the front and the back continue along one construction line, and because this is an auxiliary elevation, we're taking our heights from our front elevation. So the height that we have here is the height we're transferring across here to give us the point AB. And again, that makes sense because we've just gone from standing in front of the object to walking around the object. The object is still the same height off the ground. So in front elevation, that's the distance off the ground. It's going to be the same distance in our auxiliary. So that's our second example. For our third example, we're going to have again, pretty much the same thing, except for this time we've reversed the two views. So our plan view is horizontal and our front elevation is sloped. So going back to our true length of our lines, we know that looking in from the plan view, we're looking in perpendicular. So it's our true length is going to be projected into our front elevation. So it's the front elevation we're going to be working from this time. So because we're working from the front elevation, we're going to be drawing in an auxiliary plan view. So it's going to be looking along our true length line in elevation. Our x1, y1 is going to be perpendicular to it in elevation this time. So the plane that we're going to draw, this plane here, is coming out from the vertical plane. So it's coming out from the vertical plane like so. Like we do before, we're projecting it down to give us our point view. A and B carried along the one construction line, and this time we're taking our distances off of the XY line to the plan view. So if you remember, we had this 1-2 rule when it comes to dealing with auxiliaries. You start off with the view that you're dealing with and the x1, y1 line that you're dealing with, and you go back to the previous xy line, back one view, or one xy line. So this is our previous xy line, and we count back two views. So this is the view we're trying to draw. Back one view, back two views. So from this xy line to this view is where we're taking our measurements. So there's our distance there, and there's our distance there. And this should make sense insofar as that, well, really what we're doing is we're measuring our point out from the back wall, the vertical plane here. So in our plan view, this is the distance our object is out from the back wall, our vertical plane, and it's the same distance that we have here out from our back wall or vertical plane to our point view here. So it's the same distance. In each of the examples that we're after taking here, we've had the true length in each of the views that we are primary views. So whether it's the front elevation or the plan view, one of the views has been a true length line. In our next example here, we can see that that isn't actually the case. Our line is sloping in front elevation, it's sloping in plan view, so neither of these views are going to be a true length line. So from our knowledge of true length lines, we know that, well, to find the true length line in this case, we can do one of two things. We can take an auxiliary, or we can swing the line around, take a rebattement. So the easiest thing to do here is to take an auxiliary. So we want to look in at our line. We can take it from front elevation or plan. I always think it's easier to start off with the plan view. It's easier to imagine just walking around the object. So that's exactly what we're going to do. From our plan view, we're going to look perpendicular to the line, and we're going to create our x1, y1, so our plane parallel with the line or perpendicular to our viewing direction. So there's the plane like so. You can see the plane sticking 90 degrees out of the horizontal plane there. So we're going to project our line onto the plane to give us the true length of that. So here we can see we project our line in line with our line of sight, and we're going to take our heights from our front elevation. Because we've just walked around, the line hasn't changed height from when we were standing looking straight in front of it. So here we now have our true length of our line. So this is, I suppose, getting to where we started with the other examples. So now that we have the true length of the line, this is the view that we're going to look along to give us the point view. So we're going to look along our true length line, we're going to project a second auxiliary. So our second auxiliary, our x2, y2 line, again perpendicular to our true length line, always the same, it's always going to be perpendicular to the true length line. We're going to create our plane here, and we can see that our plane this time is at 90 degrees to our first auxiliary plane. Your plane that you create is always at 90 degrees to the plane that went before it. So we're going to project our line onto the new plane, our second auxiliary plane, giving us the point view there. Here we can see continuing along our single line like so, and we're taking our height this time using our 1-2 rule. This is the view we're dealing with at the moment. Count back 2 views, follow the lines back. This is back 1 view, follow the lines back. This is 2 views. So the plan is the view that we're going to be working from. This is the xy line that we're dealing with, our x2, y2. Count back 1 xy line, so x1, y1, and it's handy even the labeling x2, y2. So the previous one is x1, y1. So that's where we're taking our distance from this xy line to this plan view. So there's the distance we're taking it from, and there's our distance marked out, as we can see here like that. And again, that should make sense, because if we look at our 3D view here, well, the distance that we have here from our first auxiliary plane, this distance here is going to be the same distance that our point is out from it. So we're measuring everything from our vertical plane, or our first auxiliary plane. If you want to know a little bit more about how we actually get our measurements for this example here, the next video is going to be a 3D animation showing the actual object folding out, representing what you have on your sheet and going back to the 3D. So that should kind of help clarify maybe any issues that people have. I know that's in particular, this is one area that students tend to have a little bit of difficulty with, so just that's one little extra kind of resource, just that you might be able to help kind of clarify things. But that's pretty much it. Now, you mean in each situation that we've seen here, that's the total amount of possible situations that you can have your lines in. You mean, I know we're just dealing with a single line at the moment, but no matter how complicated the drawing you're dealing with, you are still just dealing with lines. So if you just isolate a single line, if you find the true length of it and look along it, you will still find the point view of it. So it doesn't matter how complicated the drawing is, the actual process that you're seeing here in every scenario they're all the scenarios you possibly deal with, so it will work for whatever drawing you're dealing with. So as always, I hope this has been of some use to you, and keep watching. Thank you very much.